Hi, everybody. Welcome to the Trends from the Trenches podcast. I'm your guest host, Jessica StLouis, a senior scientific consultant from BioTeam. I'm so honored and excited to have Moffitt Cancer Center's Research IT Department, Jarett DeAngelis, and Shane Corder with me today to talk about HPCs. When we do assessments across research institutions, the same challenges come up again and again. Collaboration is hard. Data sharing is hard. And access to high-performance computing often takes days, deep command line skills, or both. Today, we're talking to the team at Moffitt Cancer Center, located in Tampa, Florida, about how they tackle these problems head-on by redesigning how researchers access compute and data. Jarett, before we dive in, I'd love for you to briefly introduce yourself, your role at Moffitt, and what you focus on day-to-day.
Sure. Thanks, Jess. It's really fun, and I think it's going to be a good time to be here, and it's great talking with you again. My background comes generally from IT infrastructure, and more specifically than that, also, of course, we share a background at BioTeam previous to my position here. So I've been in this position now it'll be 3 years in May. And my title is Director of Scientific Computing. So my group is responsible for all of the HPC infrastructure at Moffitt, everything from a large 70-node general purpose cluster to what we consider large anyway at our scale, to a 4-node ML and AI specific machine. And now the addition of a new machine that we're really excited about, which is specifically devoted to collaborative use cases. So our group manages all that stuff. We do, everything from, some software development all the way up to, design and implementation of new cluster configurations. A lot of direct assistance of researchers with their HPC needs and everything in between.
Awesome. Shane, same for you. Can you introduce yourself and tell us how you fit into Moffitt's research computing environment?
Yeah, sure. Hi, Jess. With our background, working at BioTeam together, of course, there's that. But I've been in HPC going on 25 years. Basically in the trenches, doing everything from, design, build, implement, test, kind of the whole gamut, basically from anything that you get a box of computer parts all the way up to, supporting many different domains of science with HPC. But I've been at Moffitt since July of 2024. It's been a fantastic, year and a half ish. Couldn't be happier with my role here. I get to, I guess I basically get to build and tinker and kind of chase all the squirrels that I want to chase. So I get to build really cool things for science to help reduce the time to outcome and really help researchers push the boundaries. So yeah, that's me.
I love hearing you say reduce the time to outcome. I know that will resonate really well with our audience. Shane, do you think you could give us a quick overview of Moffitt Cancer Center for the listeners?
Sure. Yeah, so Moffitt was established in 1986, I believe, in Tampa, Florida. It's the state's only National Cancer Institute designated comprehensive cancer center, which really reflects like the national leadership in research and clinical care and education that Moffitt does. Moffitt has over 10,000 employees, over close to 500 physicians. We do a lot of great work, and 5 major research programs that really drive cancer innovation. We have population health, supported by unique interdisciplinary initiatives like the Integrated Mathematical Oncology Department. So yeah, we're really very versed in what we do, and really focused on making the biggest impact we can.
Thanks for that overview. I do want to start with asking Jarett, when we talk about institutions, collaboration and data sharing always come up as different pain points. Was this true at Moffitt as well?
Definitely. In the course of working at BioTeam, we definitely saw collaboration and data sharing come up as a challenge repeatedly. Moffitt's definitely no exception. What it looks like when you try to, do collaboration with someone involving, say Moffitt resources right now, is, you have to do things like onboard collaborators as, non-employees, right? As contractor type accounts. And that can be a really long and involved and drawn out process, right? That's if you want to actually get people to be able to come in and use HPC resources. Even if you're just trying to do data sharing, that can also get complicated in terms of dealing with like different versions of different cloud services. A lot of the well-known ones that folks will use today, we've had different attempts of trying to use those, and in various ways they've sometimes come up short in terms of is there enough available network bandwidth in and out of our network to wherever that cloud service is, or from our collaborator to wherever that cloud service is. Are there problems with keeping data synchronized between wherever it might be getting generated at Moffitt or generated at the collaborator and, into the cloud service and then into the other party? So there's all kinds of difficulties that we run into. You have to remember at the same time, while we're dealing with that, we're also simultaneously trying to help, or trying to make sure that, permissions are correctly managed, that concerns around management of PHI are properly addressed. And all of that kind of comes together to really create some massive amounts of friction when it comes to trying to collaborate with other people outside the organization.
Yeah, this definitely is something I know our audience can resonate with. And I was thinking, you're describing a problem that we hear everywhere. At some point, you guys moved from talking about this to actually doing something about it at Moffitt. Can you tell me a bit about this shift that you guys went through?
Yeah, so we're really excited about this new facility that we're just about to have go live in the next few months. So this is what we call the Collaborative Computing Center, and this was funded with a $2 million grant from NIH, an S10 grant, which is frequently has been used for things like you're going to buy a new instrument, right? Maybe a microscope or something like that. And then when you apply for the grant, you say, okay, well, here's the purpose of it. Here's, why we want to buy this thing. Here's the kind of work that we want to put it to, et cetera. Increasingly, those kinds of grants have also been used for computing equipment, because I think there's a realization on the part of NIH, the federal government writ large, that really, computing resources very much are a scientific instrument, especially in 2026. And that's only going to increase, right? With many, many different kinds of applications, everything from bioinformatics to, microscope image analysis to ML and AI. I mean, all kinds of stuff, right? So because of that, we wrote this grant in kind of a unique way and sort of described it as, we want to basically have dedicated hardware and software resources for collaborating with outside organizations. And so this is a fairly small cluster in the grand scheme of things. I mean, it's like 30 something nodes, not very big, but it's enough to be able to, do plenty of meaningful work with outside collaborators. And the way that we've got it set up is it's going to have its own dedicated internet connection. So the data plane of this system is not connected to Moffitt's at all, right? So that means a couple of different things. It starts out with the fact that permissions and so on, and sort of group memberships and other things don't have to apply from Moffitt to the Collaborative Computing Center and vice versa. So we can be really flexible with how we administer the system. And that's really powerful for us because it lets us get a lot of sort of institutional cruft out of the way, right? So that's one thing. It also has its own, dedicated compute, network, and storage. So it's got about 1.3 petabytes raw of Hammerspace high-speed data storage. And one of the great things about Hammerspace is that it has, built-in data management facilities that are incredibly powerful, where you can have rules apply to data, depending on the provenance of that data or other things happening to that data as it kind of moves through the system. And so the idea is basically, because of the fact that this is going to be a multi-tenant system, we're going to have multiple collaborators working with us at the same time. We want to make sure that, those folks that come in have lots of assurance about the security of their data, access control, as well as, data lifecycle management and other kinds of things like that. So all that together, I think, is going to create a really powerful environment. And it is sort of doing on premises what I think maybe a lot of organizations might seek to do in the cloud for this kind of, use case. The main difference being that our operational expenditures for a system like this are going to be significantly lower than doing something like this in the cloud. Especially if you're looking at utilization, maybe close to maximum for most of the time, right? You can really burn through your wallet in the cloud trying to do HPC in that way, especially if you've got to keep, storage persistent. You've got to keep nodes running to be able to service requests and so on. On premises, you don't have to worry about that stuff as much. And so, this is sort of like building our own cloud environment that we're running for the express purpose of doing research with outside organizations. So we're really excited about it.
It's definitely very exciting. I liked hearing you say there is a realization that computing resources are a scientific instrument. What I'm also hearing is that this wasn't about building technology for its own sake. It was also about removing friction so researchers could actually get to the science faster. Would you agree with that?
Yeah. The idea here is to be as low friction, especially with respect to process, as possible. Because of the fact that this machine doesn't have any, connectivity to the rest of the Moffitt network, it means that, it is simultaneously secure, from, interaction with anything in Moffitt that's not supposed to be there. And also Moffitt is secure from it, right? So we can really, this is kind of a science DMZ like architecture, insofar as there's going to be one main point of connectivity between this system and the rest of our infrastructure, and that's really just physically it's just the internet connection that we've got that's right next to the Moffitt internet connection, right? So that connection is necessarily going to be really fast, but and then from like a software and application standpoint, we're leveraging Globus both to do authentication for the whole system and data transfer. And so, Globus is software which started out as data transfer software, just, kind of an implementation of parallel grid FTP, and kind of evolved from there into a framework for doing collaborative computing across many different organizations. And so we're excited about being able to leverage that be able to use that to reduce friction in addition to the architecture that allows us to just sort of, bring folks in as we need, and as, research demands call for it, without having to worry about all of the sort of baggage that goes along with, quote unquote, main institutional account management and so on.
Nice. Could you talk a little bit more about Globus for those in the audience who may not be as familiar with it? For researchers listening, is this something that's broadly accessible? Do researchers have to have their own licensing for it?
Yeah, so Globus is a project of the University of Chicago. It's been around quite a while, but I was saying earlier that it started out as this implementation of Grid FTP, and it's kind of blossomed into several other roles at the same time. And so this is it is definitely accessible to folks that don't have institutional accounts with it. Anybody can create a Globus ID and use that with their personal endpoint software. So if I were to go and download that, I could put that on my desktop or my laptop. I could create an identity associated maybe with my institutional email or maybe with a Gmail account or whatever. And then I could start, accessing data that's been shared as a Globus collection. And when I do that, I am presenting my credentials that I created in Globus to the institutional Globus Connect server that organization is using to share their data to, do their data transfer back and forth. And if I have permission to access it, then I can, get in and do whatever I have permission for. And if I don't, I can't, obviously I can't access it. My access gets shut down. Anybody can use this. I think it is probably very much at its most powerful when you have a real Globus Connect server deployed in your organization and you've got a subscription with Globus, because that gets you access to a lot of services that you wouldn't otherwise have access to.
Nice. Shane, I want to bring you in here because this is where the experience really shows up. How does this new approach change how someone actually accesses HPC resources on day-to-day?
Well, from the collaborative computing center side of things, definitely, we're going to have a new model of HPC access, mostly for the folks at Moffitt. Most are, used to just using institutional resources. But I definitely think that, being able to collaborate with outside people, outside institutions is going to be very powerful. And I know that, just as SC this year, mentioning the Collaborative Computing Center to other cancer institutes, our colleagues and fellow HPC nerds at other cancer institutes, were very excited to hear about this development, and they think it's truly what the space needs. We're in science. We should be collaborating. We should be sharing data. We should be doing all the things to advance science and keeping all of that data and all of the compute resources and all of the knowledge kind of collapsed inside one institution. Obviously, that's worked for many instances. But I think that's the next real realm. But we're offering things like Jarett said, Globus to kind of ease the authentication piece between institutions, but also using things like Open OnDemand, which really breaks down a lot of barriers for users who are either new to HPC and scientific computing, which by and large uses Linux as the back end, and a lot of times you're dealing with schedulers, and different institutions use different schedulers, so there's a lot of stuff there to learn for researchers and users. So this Open OnDemand implementation, which we also have on our other two clusters, really breaks down the barriers and really makes accessing HPC resources much less of a hassle, much less of a learning curve. You have a web interface, and you find the thing that you want to run, you click on it, and you hit go, right, and then you have access to whatever resources that you requested on the system. So going the Open OnDemand route really kind of just opens a lot of doors for a lot of people. That it opens those doors quicker, I should say, for folks to get on HPC and start running and making an impact with the science that they're doing.
Are you enjoying the conversation? We'd love to hear from you. Please subscribe to the podcast and give us a rating. It helps other people find and join the conversation. If you've got speaker or topic ideas, we'd love to hear those too. You can send them in a podcast review.
So this makes sense, and it truly is impactful, Shane, hearing you say breaking down the barriers, decreasing the learning curve, and opening the door quicker. Do you think you could dive a little bit deeper into Open OnDemand, perhaps talking about what makes it more approachable or how it simplifies the HPC experience for those who maybe aren't as familiar with HPC systems?
Absolutely. Yeah. So Open OnDemand is a web-based HPC access system for HPC systems. So you basically log into a web portal that takes care of your authentication into the cluster, and so it essentially gives you the same type of credentials and authentication and access to HPC resources via the command line or via the Open OnDemand web interface. These web interfaces are built on passenger apps mostly that run an Nginx process in the back end to do lots of fancy things like proxying and things like that. So users, instead of give you an example, so prior to Open OnDemand, a user wanted to run RStudio, they would need to open a command line terminal, start the Slurm job. They would have to build their own Slurm submission scripts or their own srun commands, submit that to the cluster. It would get queued up, and then they would have to log in via another terminal to start an SSH tunnel, so they could then get RStudio visible on their local system. Otherwise, without that SSH tunnel, they wouldn't have any means of actually accessing that RStudio session through their browser. With Open OnDemand, it actually does all of that stuff on the back end for you. Users don't actually see any of that. They simply click on the button for RStudio or Galaxy or MATLAB or whatever. Enter in a few simple parameters like how many cores, how much memory do they need, how long of a runtime do they need, and they hit go. And then it builds all of the stuff in the back end and serves up an RStudio instance for them in their web browser. A lot of this is actually built. A lot of our apps are actually built on Apptainer containers. So instead of using LMOD or modules to load a system, a kind of a static install of say RStudio or MATLAB. These Apptainer containers go and basically build the newest and greatest RStudio app version and all of its requirements and dependencies, build all of that into a container, and then serves up that container directly through the Open OnDemand interface. So it's really powerful. You can do lots of great things with it. You can offer many different options and capabilities, and really make it customized for the particular system that you're running it on. I could go on and on about Open OnDemand. I don't want to take up the entire time with it, but
it's a great project. There's a lot to say.
There is. Yeah, you're right. And the community is fantastic. There's been a ton of development on apps and sharing them out to the community. So we don't have to recreate the wheel or collectively bang our heads too hard on any walls to get any particular app to run through Open OnDemand. So it's an amazing resource for users. It's super handy for engineers and administrators like myself to help break down those barriers, because that's really what I'm here to do is to enable scientists to run on these systems. Sure, I care, feed, and water on the systems, but in the end of the day, it's about helping researchers get their work done and do the science that they're here at Moffitt for. So anything I can do to get them to that point and make it easier for them, I say is a win. And Open OnDemand, absolutely, without a doubt, it shows up in our accounting database, in historical data about running jobs on the system. Open OnDemand is powerful, and it's useful, and it clearly makes an impact. So yeah.
Excellent. So this is quite encouraging. Thank you for that example of the user story, and thanks for helping researchers be able to actually enable their science. So it is very encouraging. And Jarett, I was wondering, could you share another use case where this made collaboration or data sharing easier?
In terms of what you mean, and by this you mean on demand or Globus?
Anything that within building this new HPC system.
Sure. Well, I mean, one of the things that we're definitely trying to improve, and Shane's been at the leading edge of this, and we're very grateful for it, is in just general accessibility of HPC to our researchers. That's like a really a prime motivating factor behind our implementing on demand on our clusters, is to make it so that HPC resources, software, et cetera, are as accessible and sort of inviting as possible to use. Right. A lot of people may not be familiar with working on the command line, but they've got a lot of great ideas and they really want to find a way to put them into practice. Well, when you've got a web interface that can present all of those abilities to the user in a really friendly way, that's going to help you get more science done faster, because it means less time figuring out what you're going to do, or how you're going to do it, and more time being able to actually interact with the system, submit jobs, and get more work done. And so that's one of the reasons why on-demand is going to be a central feature of the Collaborative Computing Center, because we can bring collaborators from around the world authenticate them with Globus, on demand, and then have them immediately be able to see a really friendly list of applications that they can use at a moment's notice, drop of a hat. Whether that's RStudio or Visual Studio Code or any number of other things that we've got set up and waiting for folks to use, and that's really enormously powerful, because it puts us in a position to offer the power of HPC to pretty much anybody who knows how to use a web browser, right? And that's a lot of people. So this is another facet of this project that we're really excited about.
I would also add, Jarett, we have researchers like literally building their own apps for Open OnDemand. Yeah, that's crazy awesome.
Yeah.
So we've got this set of tools that are just general science tools: MATLAB, Galaxy, RStudio, VS Code, just shell terminal, job submission, all of that good stuff we have in there. But we've had researchers actually build apps that use the Open OnDemand framework to serve up things directly to physicians. So, and what that means is basically like, researcher builds thing, gives access to physician who is doing, patient care or at least, some sort of like in the research terms. And then basically giving physicians who have never touched HPC a day in their life a way to interact with HPC. That is massive. That's huge. That is that's not something that a lot of folks are doing and have made happen. So there's just a ton of amazing and exciting things happening with all of our implementations of Open OnDemand, really.
Yep. Yeah. Giving physician scientists, access that's that fast to research computing resources is something we're really happy with, and it's something that has enormous potential to, you use the phrase reducing friction earlier, to really reduce friction in the process of, evaluating how a clinical trial is working or any number of other things. So we're really excited about that. And also it's for the future, the reason why our group is called scientific computing as opposed to just, research computing is that when our group was sort of, founded originally, it was with the vision that we would eventually be able to serve, clinical use cases in addition to research ones. And so the fact that we can kind of trial that a little bit by, having physician scientists who are doing clinical trials able to access these resources and provide us feedback on how user-friendly they are and how easy they are to use in the course of, doing their, just the course of working in their day. That really sets us up well for being able to serve clinical use cases in the future with other HPC resources that are more, clinically focused, that are set up specifically for clinical access. And that's a whole other world that we could talk about maybe in a different podcast. But, there's definitely a lot of stuff coming on the horizon, right, in the clinical world that looks an awful lot like HPC. Whether that's ML and AI applications or imaging applications or any number of other things. Increasingly, we need more and more compute with more and more storage and the ability to use it as effectively as possible. And I think we're blazing some trails for that at Scientific Computing and Moffitt, and we're pretty stoked about it.
Yeah, that's great. It's truly inspiring to see how this technology is helping advance the fight against cancer and enabling the physicians, plus the dual expertise physician scientists to help with patient care and their patient outcomes. I loved hearing that you're getting the user feedback. That's fantastic to help with future HPC resources. And that kind of brings me to my next thing that I wanted to talk about, which was the future. I've had a great conversation with you guys. This has been very helpful, very insightful. And I kind of wanted to end with, what are you guys looking forward to the most at Moffitt Cancer Center? And what do you think's coming ahead in the future?
Oh boy. So, new toys are always cool, right? New shiny HPC systems are always great. But I would say my biggest goal is to utilize the things that we have within our grasp now better. I want to basically tap every possible bit of power out of the systems that we have, make them as useful as humanly possible, make them as accessible, and continue to make them more accessible to more people, not just necessarily inside research, but as Jarett said, like as we go into clinical and we have other departments at Moffitt that are for the lack of a better term, maybe suffering in silence, maybe because they don't know what they don't know, that we have this, all of this HPC infrastructure at Moffitt that could, make their lives a lot easier and make their science a lot faster. So, putting out all of the feelers and all of the kind of marketing, I guess, the internal marketing, just to really kind of bring in as many people as humanly possible to the HPC systems at Moffitt to benefit from them. So yes, I want to do that with our current stuff, but we definitely want to keep an eye out, for the future. What's coming down the pike as far as technology goes that's going to benefit our researchers. As a technology nerd and an HPC nerd, that's always kind of, on the back of your head, where's the new shiny toys and how can they help me do X? So, it's definitely an exciting time with all of the new technologies, especially GPUs and accelerators and of course, quantum and all of the things, right? So all of that's very exciting and something that we're always going to keep our minds on. But yeah, I would say my goal for myself is just to continue pushing towards the best efficiency, best experience for my users, and building anything and everything that they need to do to ultimately, kick cancer in the rear end. So
Excellent. That's a great goal, Shane. How about you, Jarett?
Yeah, I have to agree with Shane about being able to better take advantage of stuff we've already got, and in addition, grow the stuff that we've got now. So one of the things I'm really excited about is expanding our capacity for local AI and ML inference on our existing hardware and in existing systems. There's a huge amount of potential for use of LLMs, VLMs, other things, in that space for all kinds of stuff, automation. There's, opportunities in bioinformatics because, genomic data is just text. So that's something that LLMs are really good at working with, right? So you can get them to do all kinds of really interesting analysis of genetic data. You can do that with foundation models in the cloud, with a lot of, friction that we talked about earlier with respect to PHI and so on. Or you can build that kind of capacity out yourself, in your own data centers, run this stuff yourself, and then get some really great results in a really secure way. We're looking at expanding our capacity in that space now. Both in the Collaborative Computing Center and in our, internal compute resources, similar capacity, in sort of two different magisteria. I don't know exactly what to call them, but two different networks, basically. But yeah, we've got that to work on and grow. We have a big digital pathology project that is, currently underway at Moffitt. Whatever we can do to support that, we're of course going to be really excited about. And yeah, there's all kinds of exciting things happening right now in cancer research that we get to participate in, and that we get to help grow as fast as possible. And so I think, despite a number of industry challenges and scientific world challenges here and there, I still think that the future looks incredibly bright for cancer research, and I'm really glad that we get to be a part of that.
Thanks, Jarett. I just want to say how grateful I am for this time together. It's clear that the work you guys are both doing will have a profound impact on many people and on cancer research as a whole. Thank you so much for joining us on Trends from the Trenches, and I look forward to our next conversation, as I definitely think we could dive deeper into many of these conversations. I'm your guest host, Jessica StLouis from BioTeam, a life science IT consulting firm at the intersection of life science, data, and technology. To learn more about BioTeam and our work, please visit bioteam.net. And thanks again for listening. If you have any questions or would like any more information about Shane's work, Jarett's work, or the work we do at BioTeam, please send me an email at info@bioteam.net, and we'll make sure the right person gets the info they need. Thanks again for listening.
Thank you for listening to BioIT World's Trends from the Trenches podcast.